Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. Remember, the program is still Manifested Online Classes. We are still continuing with simple classification of substances topic, and our subtopic is separation of soluble, solid, liquid mixtures. If you remember, in our previous lesson, we discussed or we learned how you can be able to separate a mixture of sodium chloride and sand. We say there are two methods you can use, or which are used together, which are filtration and evaporation. The first step was to put the mixture in a beaker. Once you put the mixture in the beaker, you're supposed to add water to the mixture and stir after adding water. When you stir, sodium chloride dissolves in water while sand does not. Therefore, the next step will be to conduct a filtration process. When you conduct filtration process, sand is the residue while sodium chloride solution is the filtrate. Therefore, filtration method separates sand from a solution of sodium chloride. Then after obtaining this filtrate, which is now sodium chloride solution, you carry out evaporation. You evaporate water from sodium chloride solution, and you will be left with sodium chloride salt. So that is how you are able to separate a mixture of sand and sodium chloride. I hope you can be able to describe that. Therefore, in this lesson, we are going to discuss how you can be able to obtain a solvent from a solution. How can a solvent be obtained from a solution? That is what I want us to learn in this lesson. And by the end of this lesson, you should be able to explain how you can be able to obtain a solvent from a solution. Remember again, a solution contains a solute and a solvent. Therefore, we want to explain, or we want to learn how you can be able to obtain a solvent from that solution. Therefore, separate how can a solvent be obtained from a solution. It is a simple experiment just to illustrate how you can be able to obtain a solvent from a solution. I want to write a simple procedure which we are going to use, and I will explain it to you so that you understand what we are doing. Therefore, this is the procedure we are going to use, and that is the diagram to explain what we are doing here. Step number 1, place 20 centimeter cubed of sodium chloride solution in a boiling tube or around the bottom of the flask. But in our case, we have used a boiling tube. Heat the solution until all the solvent has evaporated. You're supposed to heat until all the solvent has evaporated. So this is a solution of sodium chloride inside. So that being a solution of sodium chloride, you're supposed to heat until all the solvent has evaporated. And the solvent in this case is water. So heat until all the solvent has evaporated, then record your observations. The observation is going to be a white solid is left behind. A white solid will be left behind. The white solid left, this is salt. And the salt is sodium chloride. If we had used sodium chloride, because we had used sodium chloride, then whatever is left is a white solid. And this white solid is a salt, and the salt is the sodium chloride. All the water is evaporated. You're left with sodium chloride salt. The next step, place 20 centimeters cubed of sodium chloride solution on a watch glass. Then place the watch glass on a water bath. Then heat sodium chloride solution to dryness. If we had that, if this is the watch glass, this is the water bath. It is on top of a tripod stand. You are heating, and of course there is the wire goes to ensure there is uniform distribution of heat. If this is the solution, it's a solution of sodium chloride. That is heat. If you heat or evaporate this solution to dryness, again you are going to be left with a white solid. So the same thing is going to be left behind. A white solid will be left. Once all the water is evaporated, you're left with that white solid. Then you're supposed to record the observation, and the observation is a white solid which is left behind after all the water has evaporated from that solution. So that white solid is left, and the white solid is salt, which is sodium chloride. Then the other thing, place the liquid in tube B on another watch glass. Place the watch glass on the water bath, then heat the liquid to dryness. So you get a little amount of the liquid here. When you get that liquid, then again you repeat like you did at this point, and therefore the diagram will have a diagram like this. That is a beaker. Then we are talking about tube B. So place the liquid in tube B on another watch glass. This is the liquid, and the liquid in tube B is a colorless liquid. Therefore, the colorless liquid is on a watch glass. Then you put it on a water bath and heat to dryness. And you also observe what is going to happen after you heat it to dryness. Now, what happens when you heat this salt solution? When you heat this salt solution to dryness, water evaporates, leaving behind salt, which is sodium chloride. The water which evaporates now passes through this delivery tube as it condenses. Some of it condenses in the delivery tube, leading to formation of a colorless liquid. So the water vapor evaporates. Some of it condenses on the delivery tube, and it comes at this point, and that's why you have this colorless liquid. The colorless liquid is water. This is water, and this water does not contain dissolved salts. The water does not contain dissolved salts. The purpose of this cold water is to cool the water vapor. Once the water vapor now drops at this point, or drops through the delivery tube, it is now cooled by this cold water. So that is the purpose of the cold water at that point. Then remember, we are still looking at how can all our point of concern is how you are able to separate a solvent from a solution. And using this method, it is possible. We had a solution, a salt solution, and this salt solution is sodium chloride solution. We have heated the sodium chloride solution. Then to dryness, you heat sodium chloride solution to dryness. Then water evaporates. You are left with salt or sodium chloride solid in the boiling tube. Then the water which evaporates now is collected as the colorless liquid at that point. Therefore, the colorless liquid collected here does not contain dissolved salts. And when it is heated at this point, when you heat this colorless liquid, you obtain at the lower point. Then this colorless liquid, when you heat this to dryness, then there is nothing left on the watch glass. There is nothing left on the watch glass because this colorless liquid does not contain dissolved salts. That's what happens. This method of separation is called simple classification. Simple distillation. It is called a simple distillation method. Therefore, through a simple distillation method, we can be able to obtain a solvent from a solution. And it is possible using this method. We have heated a solution of sodium chloride to dryness. We are left with salt. Water evaporates and it is collected as a colorless liquid. But as it evaporates, some of it condenses on the cooler parts of the delivery tube, and at the end, then it is collected at that point. And again, we have seen that the function of the cold water is to condense the hot water vapor into a liquid, to condense the hot water vapor into a liquid. And that is how we are able to obtain a solvent, which is now water, from a solution. When we were heating this solution, then there was salt left. There was salt left. And this salt is because this solution was containing concentrated, or it was containing salt in it. When we heated this, there was nothing left on the watch glass because this colorless liquid, which is now water, does not contain dissolved salt. And therefore, that is how you are able to separate, or you are able to obtain a solvent from a solution. And this method, we have said, it's called simple distillation. Simple distillation. If you want to improve the condensation process, or yes, the condensation of this vapor, then you can now use another apparatus which is called a Liebig condenser. A Liebig condenser is used to improve the condensation of the water vapor to form the liquid. And when you use a Liebig condenser, then this is what to expect. Therefore, that is what is going to happen when you use a Liebig condenser. Remember, we have said that the function of the Liebig condenser is to condense the water vapor into a liquid efficiently. When this salt solution is heated, water evaporates and you are left with salt. That is when you evaporate it to dryness. Then this water vapor now passes through this point, then goes down through the Liebig condenser. This is what you are calling the Liebig condenser. Then the Liebig condenser has 2 points where the cold water is getting in, which is now on the lower side, and where the water is coming out on the upper side. This cold water, the function is to cool the hot water vapor. So this cold water is cooling the hot water vapor as it is passing through this point. When this cold water cools the hot water vapor, when it cools the hot water vapor passing through this delivery, or this passing through this Liebig condenser, this water in the process of cooling the hot water vapor also gets hot. And that is now why we have the hot water coming out on the upper side. The hot water is coming out on the upper side. But the reason why we have the cold water on the lower side and not on the upper side is to ensure that it is more efficient, because when the cold water gets in on the upper side, then it just passes so fast and getting out on the lower side, and therefore it will not be efficient in cooling the hot water. Not hot water, but hot water vapor, which is passing through the Liebig condenser. And now whatever is collected is the distillate, because the method, we are calling it simple distillation. And this distillate is now a liquid. And again, remember, we are discussing how you can be able to obtain a solvent from a solution. And that is how you are able to obtain a solvent from a solution. Therefore, understand that very well. Maybe to connect or to repeat a little bit what I've said, that in this method, you are still able to separate the solvent from this solution, but this method is not very efficient in that separation compared to this. Therefore, the function of the Liebig condenser here is to make the separation of the solvent from the solution more efficient. It becomes more efficient when you use a Liebig condenser than when you don't use it. And I've explained it to you how the Liebig condenser is of great importance. It has 2 points where the cold water is getting in on the lower side. This cold water which is getting in is cooling the hot water vapor from this position. When this salt solution is heated, when you heat this salt solution, then the water vapor evaporates, then follows this path. The cold water which is getting in at this point is cooling that hot water vapor because it must be hot because it has been heated at this point. Then that cold water in the process of cooling or in the process of condensing the water vapor into a liquid, then it also gets hot. And the hot water is now the one which is getting out on the upper side. And that is how you can be able to obtain a solvent from a solution. Therefore, put that always in mind, and again ensure that you can be able to explain that very well. Ensure that you can be able to explain that very well. Therefore, the method is simple distillation. And that is a method you can use to obtain a solvent from a solution. Therefore, that brings us to the end of our lesson today. But before that, I will leave you with this question, which is the assignment today. And the assignment is, name the method which can be used. Name the method which can be used to obtain water, which is the solvent, from a solution of sodium chloride. Name the method you can use or which can be used to obtain water from a solution of sodium chloride. That is a simple one. In the next lesson, we'll be discussing the separation of liquid mixtures. See you in the next lesson.